One characteristics of images formed by a plane mirror. One of them. TT. One characteristics of images formed in a plane mirror. TT doesn't remember. Okay, Christine. One of the characteristics of images formed by plane mirror. One image is hey, everybody is quiet. Characteristics of images formed by a plane mirror. Christine, image is pardon?
Please, the distance with sorry, the image is erect.
Image is erect. Ella.
Please, the distance.
Christine, image is erect or upright. Ella.
Please, the distance from the object to the plane mirror is equal to the distance from the image to the plane mirror.
So
Distance of the image to the
object distance, image distance equal. Yasmin.
Mr. Ija, please, the image is virtual.
Image is virtual. Aisha. Theater. Okay, Jasmine again.
Please, the image is laterally inverted.
Image is laterally inverted. Okay. Thank you. So object distance, image distance equal. Object height, image height the same. Image is virtual. And lastly, image is laterally inverted. Okay. Formation of, I'm coming. If the ray is perpendicular to the mirror, meaning it is making an angle of 90 with the mirror, it will reflect along the same path. So incident ray indicated by the arrow pointing to the mirror, and reflected ray indicated by the arrow moving towards the image. And this will happen because this ray is perpendicular to the mirror. Okay. Now, the second rule is that a ray at any other angle, okay, reflect and obey the principle of the laws of reflection. A ray at any other angle reflects and obey the laws of reflection. And there are two laws of reflection. Angle of incidence equals angle of reflection. Janice. Okay, so these are the two rules we are going to use to draw our ray diagram. Now, so let's go through the rules. A ray of light perpendicular to the mirror reflect along the same path. Okay, now we see as a result of reflection, before you see an object, rays of light must come from the object, okay, must reflect or must come from the object and be captured by your eye. Okay, and what's the source of the ray or the light coming from the object is always from the sun. So before you see somebody, we have beams of light or rays coming from the object, being reflected from the object, okay, incidented from the sun, reflected from the object, and then picked by your eyes. Okay, and your eyes does the interpretation, meaning that we see as a result of reflection of light from an object. Please, are you okay? This explains the reason why when you are in a place and there's no light, you cannot see. You can't see because no light is reflected from the objects around. The moment light around is on, okay, the objects reflect light from the source and then it's received by the observer's eye. So we see as a result of reflection. Meaning that if you see an object, then it means the rays coming from the object are many beams of light or rays comes from an object. In ray diagrams, we indicate or we form an image using a maximum of just 2-3 rays. Even though there can be lots of light coming from an object, we only draw a ray diagram using a maximum of 3 rays. Please, are you okay? Hello?
Yes, please.
All right, so let's go ahead and then indicate the image. So a ray of light traveling perpendicularly to the mirror reflect along the same path. Then let's use maximum of 3 rays coming from the object. Another ray of light coming at an angle, this time not perpendicularly. So another ray. Now the rule says that when a ray hits a ray at any other angle, reflect and obey the laws of reflection. So incident ray, then reflected ray. Mirrors reflect. So when light hits on it, it will reflect. Now the reflection must obey the laws of reflection, meaning that angle of incidence equals the angle of reflection. So this is, let's use this to represent the normal, meaning the normal must divide this into 2. Okay, now, so these are 2 laws. Let me use a maximum of 3 rays. So another ray hitting the mirror at any other angle must reflect. The reflection must obey the laws of reflection. Now, before we draw the image, you see, one of the characteristics is that object distance must be equal to image distance. So the distance from this point to the mirror, assuming is this, we must have the same behind the mirror. So I'm just estimating. So if this is X centimeter, from the mirror to the image must also be X centimeter. So what we are going to do is that we are going to trace the reflected ray to this point, which will represent the image. Then trace this one too to the same point. So this is the reflected. Now we trace the other one, the perpendicular one, to it as well. So if this is the object distance u, from here to here will also be the image distance v, and object distance must be equal to the image distance. This point becomes the image. This point is the image. So this is how to draw the image of a point object by a plane mirror. Let's go through it again. Let's use the rays again. So we are drawing using ray diagram to describe image formation in a plane mirror. And in doing this, we are using two rules. The rules are that one, a ray of light perpendicularly to a mirror. So if this is the object and the ray is perpendicularly to the mirror, it will reflect along the same path as the incident ray. Now, one of the characteristics is that object distance equals image distance. So let's measure this distance from the object to the mirror. So if this is around 18 centimeter. So we measure 18 centimeter from the mirror as well. So roughly, we expect this point to be the image. So now, because the image is virtual, these lines at the back must be broken line to indicate virtual image. So this is one of the rules, that a ray perpendicularly to the object reflects along the same path. Now we apply the other rule, that a ray hitting the mirror at any other angle must reflect and obey the laws of reflection. But the reflected ray must be traced to this point. You don't just draw it. This is the reflected ray, and it must be traced to this point, so that reflected. So even the two rays are giving us the position for the image, but we can also use a third ray, maximum 3. 2 or 3 can be used to describe an image. Incident. When it hits the mirror, it must be reflected. So you trace the reflected ray to this point, so that you can have the law being obeyed, that object distance equals image distance. This point is the image. Okay, now we can see that, yes, U equals V. Image is virtual. Why is it virtual? Because it is formed behind the mirror. Object distance must be equal to image distance. As for laterally inversion, we can't see that we can't see laterally inversion because this is a point object. So this is how an image can be formed when the object is just a point object. Please, any question? All right, let's look at an extended object. What is an extended object? When we talk about an extended object, we mean an object that has head and a tail. An object with a head and a tail or foot. In ray diagrams, we represent an extended object as just this, a vertical line with an arrow representing the head and then a dot representing the foot or the tail. So this is an extended object. So in ray diagram, a human being is represented as this. Your head, this is your height, object height, and then your foot. Please, is that okay? Are you there?
Yes, please.
Yes.
Yes, please.
So how do we use ray diagram to draw the image of an extended object? Then we use letters. How do we draw what will be the image of the letter A, B, and so on and so forth in front? So we are looking at an extended object. We draw the mirror. Then we draw a horizontal line passing through the center of the mirror because the foot must actually be on this line. Oh shit. Use the longer. So the object's foot is on the line. So this is the object, the extended objects, the head and then the foot on the line. We have to use ray diagram. Now, the object distance is from the mirror to this point. Okay, so if I estimate this is around, I think 13 centimeters. So I must get the same distance as the object image distance. Because object distance equals image distance. Now, I'm going to draw the image of the head because the foot of object and image will always be along this line. So let me get the image of the head. A perpendicular distance, a ray, which is perpendicular to the mirror, reflect along the same path. A broken line to indicate this as well. Now, a ray of light from the head hitting the mirror at any other angle must reflect to obey the laws of reflection. But it must reflect, and then the reflected ray must be linked to this point. So this is a reflected, okay. Yasmin.
Yes, Mr. Yeah, please. I'm sorry, but the light is reflecting on the board. It's quite difficult to see the diagram.
Really?
Yes, please.
Yes,
Oh.
please.
Okay, let me use this end to see if it would work.
The light is also there too.
Hey. Let me see if taking a shot and then dropping it on the platform would help. So let me use.
Thank you.
Can you see? I want to use the down part of the board. See if the problem will be solved a little bit. Do you have reflection down here, or you can see whatever is here?
Yes, please.
So this is the object O. Object distance must be equal to image distance. So you need to measure this, the object distance. You need to measure. So from the distance taken, this is around 14. So I measure the same distance for the image. Then object height must be equal to image height. So if this is X height, I must also have X height. You need to measure. Then you use the rule, a ray of light perpendicular to the mirror would reflect along the same path. Okay. Since the image form will be virtual, you indicate this ray at the other end behind the mirror using broken line. Okay. Then you use a ray of light at an angle, coming from the head at an angle. This ray reflects, but you must connect this ray to the height taken. This is the height of the object. So this must also be, the reflected ray must be connected to this. So this is the reflected ray. And this position gives you the image. This is the image. In fact, you can even have a lot of rays to indicate the foot and then the head. So, but usually in ray diagrams, we don't, if you use a lot of rays, maximum 2 for this and then 1 or 2 for the foot. So let me use another ray for the foot. This is the incident, a ray from the foot, meaning this will be another one coming perpendicularly to it, would reflect, but the reflected ray must be connected to the foot of the image. So this is reflected and so this is using a ray diagram to form an extended object. Now let's use this to draw the image of letter F or any, I think F, G, any letter it plays in front of the mirror. So let's clear this and then use
Mr. Dear, please, I want to copy it.
pardon.
Please, I wanted to copy it.
Oh, but hurry up. You need to let me know. Once you don't tell me, how do I know you are drawing?
Please, I've gotten it.
So the letter A, F, G can show the lateral inversion. So the letter F, just a sketch. So this is letter F in front of a plane mirror. Okay, we have to use ray diagram too. Now, object distance must equal to the image distance. So get this distance. And it must be equal to where the image would also be. So this position gives us the foot of F. Now, this line, a ray from the topmost part of the mirror, must give us the same thing. Okay. Once we have determined this, then we can draw a vertical line to join these 2 points. But it must be broken because this point is the image. Then a ray perpendicular to this would also form this part. Now we measure if this is from here to here is F, or this distance, we must have the same thing at the other end. This distance from here to here, we must have the same distance. Okay, so we deepen these 2 points. To give us, then we deepen this to give us the letter F. So this becomes the image of this letter F in front of the mirror. And this is giving us the lateral inversion. Okay. When you look at it, it's like it looks to be tilted horizontally. It's like having the phone positioned like this. And then when it came to the back, it is turned this way. Okay, it's like this. But at the back of the mirror, it's being turned laterally. Please, is it understood? Mommy?
Please, I said that the image was supposed to be in broken line.
Oh, you see, I didn't do this in broken line for you to, so that you will see clearly. If I break it, and you can see, that's fine. But the reason why we draw this in a broken line is that the image here is virtual. Okay. But whether broken or thick line, you are not wrong. This is the object. This is the image. I want you to do it. Try it with the letter K or P. Do it using the letter P in front of the mirror. So 5 minutes. Try it with the letter P to see if you have the lateral inversion. I'm giving you 5 minutes. Quickly try it. Let's see. So let's see. The letter P. The letter P is just like F. The only difference is that for P, P should look like this. That is if you want to have a stylish P. A stylish P is like this. So the same rule. The rule is that the distance, the object distance from the object to the mirror must be the same. The object height, this height, must be the same. So if this is a horizontal line drawn from the head of P, must be the same. Okay, now you measure this. This is roughly 11. So you measure 11 from this end as well. And so this will be for P. Then a horizontal line from this must give us the same value. Then you measure from here to here. Okay, and so that you also get the distance from this point to this point. And then you join it. You join it. And you have the image of P, which is laterally inverted. So at your free time, just try with all other letters, A, G, B, and so on and so forth. It's not difficult. All right. Okay. Now let's go to some calculations in mirrors. Some calculation works under mirror. Now, Christine, are you there?
Yes, please.
People are just quiet. So, a mirror, let me draw a horizontal mirror to explain this. Mirrors reflect light. So if this is the mirror, this is the coated end. Because we are measuring angle of incidence, or light is expected to incident on the mirror, you need to get the normal. The normal is always perpendicular to the surface of the mirror. So a ray of light incidenting on the mirror. Rays are indicated by arrows. So this is an incident ray, meaning this is the angle of incidence I. The angle of incidence is always equal to the angle of reflection. So if this is X, this must also be X. And this is the reflected ray. This is R. R can also be equal to I because angle of incidence equals angle of reflection. So this can also be represented by I. This angle from the mirror to the incident ray is known as the glancing angle, theta. Let me use, so theta is known as the glancing angle. Glancing angle, the whole class. The whole class, I want you to repeat it.
Glancing angle.
Glancing angle.
Glancing angle. Now, our task is to determine the angle of deviation. The angle of deviation. Angle of deviation. What do we mean by deviation? This ray is supposed to go straight. The original part of the incident ray is this. This is its path. But by virtue of its interaction with the mirror, its path is changed. Instead of going straight, it is bent. So if we are looking at how much has the incident ray been deviated, it is this angle. This whole angle is what we are calling as angle of deviation, sigma. So we are using sigma to represent angle of deviation. Okay. Originally, this is the part of the incident ray. Incident ray. Its path is deviated or bent due to the reflection from the mirror. So instead of moving down here, its path is changed to this part, the part of the reflected ray. So if you are looking at how much the ray has been deviated, this is the amount. Okay, so we are looking for this amount, which we are calling as the angle of deviation. How do we determine this? We are saying angle of incidence equals angle of reflection. So if the angle of incidence is I, the angle of reflection can also be I or RR because they are the same. Now, what is the totality of this whole angle from the part of the incident to its deviated? What is the value of this whole angle? What's the magnitude of this whole angle? Represented by the semicircle. Yes. Oh, what's the whole value, magnitude of this angle represented on the semicircle?
180.
So 180. Now look at this. We are looking for this angle, the angle of deviation. So if the whole angle is equal to 180, now it means that when we subtract this angle from 180, we will have this angle. Are you okay? If this whole angle is 180 and we are looking for this, then it means if we subtract this angle, which is 2i from 180, we'll get this. So the deviation is equal to 180 minus 2i, or deviation is equal to 180 minus 2r. So in mirrors, angle of deviation is given by this value. That tells the extent to which the incident ray has been deviated. Please, understood? Is that okay?
Yes, please.
All right. Then let's apply this in solving questions. Put this question down. Two plane mirrors are positioned. Are you writing? Are you writing?
Yes, please.
Two plane mirrors are positioned perpendicularly to each other as shown. A ray of light, a ray of red light, a ray of red light is incident on mirror 1 at an angle of 55 degrees. A ray of red light is incident on mirror 1 at an angle of 55 degrees. This ray is reflected from mirror 1 and then strikes mirror 2. This ray is reflected from mirror 1 and then strikes mirror 2. I determine the angle at which the ray is incident on mirror 2. Determine the angle at which the ray is incident on mirror 2. Then I draw the ray of light as it is reflected from mirror 2. I draw the ray of light as it is reflected from mirror 2. So this is the problem of the day. So let's clean the board and then go through this. We are told there are two plane mirrors that are perpendicularly to each other. So we have mirror 1 and mirror 2. The two mirrors are perpendicularly to one another. So mirror 1 and then mirror 2. Mirror 2. So these two mirrors are perpendicularly to each other. So this is mirror 2, and this is mirror 1. Then the second information is that a ray of red light is incident on mirror 1 at an angle of 55 degrees. This 55 degree given is the angle of incidence. Okay. So a ray hits on mirror 1 or incident on mirror 1. So there is a ray interacting with mirror 1 and makes an angle of incidence of 55 degrees. So draw the normal to this. This angle is 55 degrees. Now, when a light ray incidents on a surface, it must reflect. So this is the reflected ray. It will reflect at the same angle because angle of incidence equals angle of reflection. So 55 degrees. Please, are you okay so far with what I've drawn? Are you okay?
Yes, please.
Then it goes on to say that this ray is reflected from mirror 1 and then strikes mirror 2. So incident reflection from incident reflected from mirror 1 and then strikes mirror 2. When it strikes mirror 2, what do you think would also happen? What do you think will happen? Hello, when the ray strikes mirror 2, what do you think will happen? Oh, no one is talking. When the reflected ray from mirror 1 strikes mirror 2, what do you think will happen?
Please, I think it will bounce. So
This is a mirror and we have one end coated. Certainly reflection will also occur on mirror 2. Please, I don't want teaching and then students view waste time. Just give me your views. Do not waste time. While this is also a mirror, this will incident and also will reflect. And the reflection would also obey the laws. Angle of incidence must be equal to angle of reflection. So it will also reflect here. So this becomes the incident, this becomes the reflection. The normal dividing this angle must also be shown because this is another second mirror. Okay, now the question is that I determine the angle at which the ray is incident on mirror 2. Determine the angle at which the ray is incident on mirror 2. Angle of incidence from mirror 2. This becomes the incident ray to mirror 2. And so this angle becomes the angle of incidence to the mirror 2. Angle of incidence is equal to angle of reflection. So the question asks that we determine the angle of incidence to the mirror 2. How do we determine it? 55, 55, because angle of incidence equals angle of reflection. If this is 55, don't forget, once this is a normal, the angle from the normal to the plane mirror is 90. This angle must be 90. This angle must also be 90. So look here. If this is 55, what will be this? What will be the glancing angle? If angle of incidence is 55, what do you think will be the glancing angle? The normal is perpendicular to the plane. If the angle of incidence is 55, what will be the glancing angle? Anybody can answer. None of you is ready to contribute.
Please 35.
How did you get 35? How did you get it?
Please, I subtracted 90 from 55.
So
It's
the
55
normal,
from 90.
exactly, the normal is perpendicularly to the mirror. So if this is 55, this will be 35. Once this angle is equal to this angle, the angle here would also be equal to the angle here. So if this is 35, this must also be 35. Now, we have a right angle triangle, 35, 90, and this unknown angle. Okay, if we are able to determine this unknown angle, we can find the angle of incidence I. So do it, determine this for me, and then let us find the angle of incidence I to the second mirror 2. Start with, I'm giving you 2 minutes. Think through it and share your answers with me. So determine X. When you find X, then we determine I. Are you true? Are you true with the value of X?
No, please.
No, please.
Hurry up. This isn't something to waste time. It isn't anything difficult to waste time. Angel, what did you make for X? Oh, Yasmin. Yasmin, what did you make for X?
Mr. Dia, please, I'm stuck.
Eh? Christine, what did you make for X?
Please, I got 55
This
degrees.
is this isn't, it should be 55. You have a right angle triangle. This is 35, this is 90. What is X? So 90, it's not even 90 plus whatever. These two must also, once this is 90, this must sum up to 90 because sum of angles in a triangle 180. So if this is 90, then this two must also be 90. So 35 plus X is equal to 90. Therefore, X is equal to 90 minus 35. This must be 55 degrees. So if this is 55 degrees, what will be the angle of incidence to the second mirror? What will be I? What will be I?
Please 35.
So 35 because 55 plus I must also be.
I-
So angle of incidence to mirror 2 is 35 degrees. Okay. Now, what is the angle of deviation of mirror 1? What is the angle of deviation of mirror 1? I've taken you through how to find angle of deviation. So use whatever we found to determine the angle of deviation to mirror 1. Sigma. Angle of deviation to mirror 1. Are you done? Are you done? Yes. Are you done? The angle of deviation to mirror 1. What did you make for angle of deviation? Janice, Christine, relax. Janice, what did you make for angle of deviation?
Sir, please. I got
Janice,
please 70.
Christine, what did you also get?
Please, I got 110.
Yasmin, what did you get?
Please, I was getting 90.
You got 90.
Yes.
I said the angle of deviation to mirror 1. So this is what I mean. What I mean is that this ray to mirror 1 is expected to go straight. But due to its interaction with the mirror, its path is changed. So the original path as against its new path, the angle between them gives us the angle of deviation. So if we are calculating for the deviation to mirror 1, it must be equal to, since this whole angle is 180 minus this angle, 2 times the angle of incidence. So 2 times 55. So this is 180 minus 110, giving us 70 degrees. So the angle of deviation to mirror 1 is equal to 70 degrees. Is that okay? Class, is that fine?
Yes, please.
What about the angle of deviation to mirror 2? Sigma to mirror 2. Calculate that for me quickly. Yes, Ella. Ella, your hand is up. Or it's a wrong hand. Angle of deviation to mirror 2. Jasmine. Jasmine. Oh, she's also gone. Ah, Jasmine, aren't you there?
Yes, Mr. Dear.
What
Please,
did
I'm
you make?
struggling a bit.
Where you struggle. Mo. We've answered the first one. This ray is supposed to go straight. It did not go straight. Because of the mirror, its path is changed from this straight path to this. So this becomes the angle of deviation. What is your struggle? Janice. Janice, go ahead.
The 110. 110.
Ella. Let me also pick what Ella had. Mommy, what did you get? Or what have you had?
110.
Tiata, what have you had?
110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110. 110 degrees.
Okay, let's see. So this is the extent of deviation. This is 35. This is 35. So the deviation to mirror 2 is equal to 180 minus 2 times 35. 2 times 35 is 70. 180 minus 70. This is equal to 110. This simple. Me, when I teach you and you don't talk, you demotivate me. So you have to also think through and then give views. When you are wrong, then I correct it. Than just expecting that I will just be doing the talking. I don't teach like that. So please learn how I am and then dance to my tune. Another question. You, Janice, you know, and you are quiet on the platform. Listen and then put down this question to 2 plane mirrors. 2 plane mirrors, M1 and M2, are inclined at an angle theta as shown. I'll draw it for you. 2 plane mirrors, M1 and M2, are inclined at angle theta as shown. A ray of light 1, which is parallel to mirror 1. A ray of light 1, which is parallel to mirror 2. Mirror 1 strikes mirror 2. We'll go through it systematically. So a ray of light 1, which is parallel to mirror 1, strikes mirror 2. And after 2 reflections, the ray 2 becomes parallel to mirror 2. And after 2 reflections, the ray 2 becomes parallel to mirror 2. Find the angle theta.
Mr. Dia, please, can you read it again?
2 plane mirrors, M1 and M2, are inclined at angle theta as shown. A ray of light 1, which is parallel to mirror 2. A ray of light 1, which is parallel to mirror 1 rather, strikes mirror 2. A ray of light 1, which is parallel to mirror 1, strikes mirror 2. And after 2 reflections, the ray 2 becomes parallel to mirror 2. Find the angle theta. In the first question, the 2 mirrors were perpendicularly, meaning they make an angle of 90 between them. In the second question, the angle between them is theta. So this, I'm using this to be M1. The angle between M1 and M2 This is M2. And the angle between them is theta. So that's the first information of the question. We have the two mirrors inclined at this angle. Now let's continue with the information. So two plane mirrors M1 and M2 are inclined at angle theta as shown. A ray of light 1, which is parallel to M1. So we have a ray of light 1, and the ray of light 1 is parallel to M1. So I draw a ray of light which is parallel to M1. So all that I need to do is that I draw a ray which is parallel to M1, and this is light 1. So you take the question step by step. A ray of light 1, which is parallel to M1, strikes M2. This ray strikes M2. Okay. It strikes M2, and after 2 reflections, when light 1 strikes M2, it undergoes 2 reflections. So 1 reflection. The second reflection is such that and undergo a ray of light 1, which is parallel to M1, strikes M2. And after 2 reflections, the ray 2 becomes parallel to M2. And after 2 reflections, 2 reflections, we have the ray 2 becomes parallel to M2. So this is 1 reflection, and then this is a second reflection. After the second reflection, we have light ray 2, and this light ray 2 must become parallel to M2. So this becomes light 2. This is the information. Please, are you okay with how the diagram is drawn? Are you okay?
Yes.
Yes, please.
So the whole thing is that you are told light ray 1 is parallel to M1. So it strikes M2 and is parallel to M1. And after it's undergoing 2 reflections, 2 reflections, light ray 2 becomes parallel to the mirror M2. Okay. Now the question is that we are to determine the angle of inclination between the 2 mirrors theta. So how do we get that? Open your eyes and then. So to mirror 2, this is the incident ray, this is the reflected ray. There must be a normal because the law of reflection must be obeyed. That the incident ray, the reflected ray, the normal at the point of incident must lie in the same plane, and the angle of incidence must be equal to the angle of reflection. So if this is the normal, then this angle must be equal to this angle. So assuming this is I, this will also be I. All right. Now to mirror 1, this is the angle of incidence, this is the angle of reflection. Let's draw a normal. a normal which divides the true angle into two. If this is x, this is also x. Are we okay? Hello, are you okay?
Yes, please.
Now, if this is x, what is this angle? If this from the normal n1, n2, if this is x, what will be this angle? What will be this angle? Of course, once this is a normal and this is x, this must be 90 minus x. Janice,
Mr. Dear, please, I can't see what's on the board clearly. The light is reflecting.
let me take a shot and then send it.
Yes, please.
So it's been sent to the platform. Okay, now, so ideally, once this is, we have two normals, n1, n2. Okay, once this is x, then the remaining angle must be 90 minus x. By then, you see, look at light ray 2 and mirror 2. Light ray 2 and mirror 2 are parallel. We are told that light 2 is parallel to mirror 2. Okay. Now, in mathematics, when two lines are parallel, what do they have in common? Or what do parallel lines have in common?
The angle is equal to 0.
No. When two lines are said to be parallel, or what you call as parallel, what does it mean? Let me draw something.
They don't meet.
Yes, they don't meet. It's true. Apart from the fact that they don't meet, they also have, look at what I'm drawing here. I have two lines here, this line and then this line. This is 1 and 2. If line 1 and 2 are parallel, what does it mean? They don't meet.
They are forming the same angle.
They are what?
Forming the same angle.
Yes, they have the same slope. If you look at the horizontal line or the base to the two lines, if they are parallel, it means that the angle between this line, L2, and the horizontal, if this is theta, we must have the same angle between 1 and the horizontal. So if this is theta, this must also be theta. So we said that parallel lines have the same slope. Parallel lines have the same slope. Okay. Now, when they are horizontal, when the two lines are horizontal, if you draw these two lines horizontally, then you can say that, okay, then the angle between this one and 2 is 0. So whoever said 0, the first situation, this is it. It applies to horizontal lines. Now, if they are directly vertical, like this, then the angle between the two lines, 1 and 2, must then be 90. Generally, all that we are saying is that when two lines are parallel, they have the same slope. Class, is that okay? Or gradient,
No,
right?
please.
Okay.
Miss,
So look here. We are told that mirror, the light ray 2 and mirror 1 are parallel, meaning that the angle between light ray 2 and mirror 2, if this is theta, then this must also be theta. Why? Because this and this are parallel. Class, are you okay? Or let me redraw. Let me redraw it here. This is theta. This is mirror 1 and mirror 2. This is mirror 1. Light ray 1 is parallel to mirror 1. So this is light 1. After 2 reflections, we have light ray 2, which is also parallel to mirror 2. The angle between the mirrors is theta. Now, this is what I'm saying. Because mirror 2 and mirror light 2, because they are parallel, if the angle between the two mirrors is theta, this angle must also be theta. When this is the incident, this is the reflected incident to mirror 1. These are reflected from mirror 1. When I draw a normal, we will have angle of incidence I equal to angle of reflection. So we can say that if this is theta, then this must also be theta. If you remember, when we had 50, 55, this was also 55. When this was 35, this was also 35. So if this is theta, this is also theta. Class, are you okay? Are you okay?
Yes, please.
Then we apply the same thing here. Mirror 2 is also parallel to light 2. So incident ray, reflected ray, when we draw a normal through it, this is I, this is also I. Angle of incidence equals angle of reflection. Okay, now because mirror 1 is also parallel to light ray 1, the angle between mirror 1 and mirror 2 must be the same as this angle. So if this is theta, please, these two are parallel. So if the angle between this is theta, then this must also be theta. Parallel lines have the same slope. So if this is theta, this will also be theta, because angle of incidence equals angle of reflection. Okay, so theta, theta, so that we have equilateral triangle with interior angles theta, theta, theta. So to find theta, we sum up the total angles within this triangle A, B, C. So when you sum the angles, you have 3 theta being equal to 180 degrees. Therefore, theta is equal to 180 degrees over 3. And this is equal to 60 degrees. It means that when you do the analysis, the angle between the two mirrors, M1 and M2, must be 60 degrees. So theta is 60. Theta is equal to 60. So I'll look for, I think this is a bit, anyway, I won't say it's difficult, but then because you are new to some of these things, you need to have much experiences to understand this calculation. So I'll look for simple questions for you to to be trying. The next area we have to look at and reflection are spherical mirrors. We've done plane mirrors, spherical mirrors. Under spherical mirrors, we have two types. We have what we call as concave or converging mirror, and convex or diverging mirror. I don't know if you've seen a kind of mirror whose surface curves, or you are only used to plain mirrors. Have you seen a curved mirror before? Class?
No,
Has anyone-
please.
You haven't seen a curved mirror before?
Maybe I've seen it, but I don't know whether that's a curved mirror.
Where did you see it? Where did you see something which looks like curved? We have curved mirrors, okay? And those mirrors are such that they either, you see, for plain mirror, it is plain, equal surface area. So all the mirrors we use, okay, for dressing, the surface area is straight. The reason for which we call it as plane. So if you indicate one side to be the coated part, the other side is flat. But we have mirrors, some mirrors that curves inwardly. So we have the other side coated, but the other side which reflects light is curves inwardly. Then we have another mirror that curves, whose reflecting surface curves outwardly. It curves like this. This is an example of this. So when it curves inwardly, we call this as concave mirror. So all concave mirrors curves inwardly. I'll let you see where to find this kind of mirrors. Let's just start. You see, this is a torchlight. The torchlight, the inner part, that inner thing which reflects light, curves inwardly. So this is an example of a concave mirror. This is an example of a concave mirror. The reflecting parts or surface curves inwardly. Then the other one, whose reflecting surface curves outwardly, can be seen in car mirrors, side view mirrors. You see, the mirror used, okay, in automobiles, okay, where the driver views, okay, from side, the side view mirror, and then the head view mirror of cars. They are not just plain mirrors. They are concave mirrors. This kind of mirrors curves outwardly. So this one curves inwardly, and then the other one curves outwardly. So all mirrors, the spherical mirrors whose reflecting surface curves outwardly, are termed as convex mirrors or divergent mirrors. whereas those ones whose reflecting surface curves inwardly are known as concave or converging mirrors. So from today onwards, when you see the side view mirror of cars and then the head level mirror, feel the surface. It isn't just flat, it curves outwardly. Is that okay? It curves outwardly. These are what we are calling as spherical mirrors. The nature of image formed by them is different from the images formed by plane mirrors. The reason for which we use them in different functionalities. Okay, we use them in different functionalities. Please, if you have any question, ask about spherical mirrors. If you have any question. All right. So we've looked at concave or converging. Now the question is that why do we call those mirrors that curves inwardly as converging? Why do we call those mirrors that curve outwardly as divergent? So, as I said, a concave mirror curves inwardly. So this is the coated end, and this is where it reflects light. Now, the reason why this is termed as converging mirror is that when you incident rays that are parallel, when you incident parallel light or rays or parallel beam of light to a converging or concave mirror, this mirror has the ability to bring all reflected rays to a common point. So all reflected rays are converged at one point in front of the mirror. So these are parallel rays. So all parallel rays are converged at a common point in front of the mirror. After reflection. So here, reflected, 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 and they are all brought to a common point in front of the mirror. This is the reason why concave mirrors are termed as converging mirrors. Converging because all parallel rays are converged at one point in front of the mirror. Then the other one, which is convex mirror. For convex mirror, when you incident rays that are parallel to the mirror, this mirror also has the ability to spread out, diverge reflected rays. So parallel rays after reflection are diverged, they spread out. They all spread out after reflection. So these are the reflected rays. The reflected rays are diverged. They spread out. So this is also the reason why this convex mirror are also termed as diverging. So convex or diverging, and concave or converging mirrors. Please, are you okay? Hello,
Mr.
class, are you
Edia,
fine?
please can you send a picture? Please can you send a picture of the concave
Converge.
mirror? I can't really see the converging.
Okay. Okay, so it's been sent to the platform. So simply concave or converging, convex or diverging mirrors. It's 9 o'clock. This is where we draw the curtains on today's meeting. We'll continue on Thursday. All right. Okay. So good night to all of you. Bye-bye.
Good
Nice,
night,
Mr.
Mr.
Edia.
Edia.